Okay, in this lesson we are going to go over a review of formulas for the areas of different kinds of shapes. So we're going to start with squares, and rectangles and triangles. Area is just simply the space inside a two-dimensional shape. Okay, and the units that we use when we are measuring area are squared. So if you have a look here, 3 meters, the little 2 up here, we say 3 meters squared or millimeters squared. So whenever we're talking about an area, our units are going to be squared. So let's look at a square here, a 5 by 5 square. The formula for the area of squares and rectangles is the area equals L times B. L is the length, B is the breadth, how tall it is. So let's have a look. Our square here is 5 by 5. Multiply that to get the 25. The units are centimeters, but because it's an area, it's centimeters squared. And then the same with our rectangle, length times breadth. So we've got 8 by 4. 4/8 are 32. The units are meters, and it's an area, so it's meters squared. So nice and easy with those. Hopefully that is something you can remember from previous year's work. Triangles. We've got a formula for triangles. The area of a triangle is half times the base times the height. Now the base could be either side, it doesn't matter. So we'll use the 12 in this case. We say it's got a base of 12 and a height of 10. So we simply substitute those in to our formula to get the area of this triangle equals half times the base times the height, and that works out to be 60. The units are centimeters, but because it's an area, it's squared. Now you'll notice it wouldn't matter if we rotated that triangle and had the 10 on the bottom, it would still work out the same. So the base doesn't have to be the one at the bottom. It's one side times the other side multiplied by half. But here's where things get a little funky. What about if I had a triangle like this one? This one was a right angle triangle, and it's easy to see where the base and the height are. And you'll notice that the base and the height meet at this right angle. Well, it's the same with this triangle. It's got a base and it's got a height, and they meet at a right angle. So in this case, we would be half times the base of 8 times the height of 6. So this one has an internal height. The right angle triangle, the height is on the triangle. This one, the height is inside the triangle, but it's the same formula, half times base times height. What about this one though? This one hasn't got the height either on or inside the triangle. It's outside the triangle. So this is a bit of a weird case, but guess what? The formula is still the same. It's got a base of 5, but the height where it meets the base at 90 degrees happens outside the triangle. That's okay. We still use the same formula. It's half times the base times the vertical height, which happens to be outside the triangle. All right, so far so good. That's squares, rectangles, and the 3 different types of triangles. But we've also got some other special quadrilaterals, and a quadrilateral is just a shape that has 4 straight sides. So this one has 4 sides. This has 4 sides, and this has 4 sides. And the names of these shapes, let's see if you can remember them from previous years. This one is a parallelogram. We know that because it has 2 pairs of parallel sides. These top ones and these side ones are parallel. A trapezium only has the 1 pair of parallel lines. The top and the bottom here are parallel, the sides are not. And this one has 4 sides, all are of the same length. In this case, it's a rhombus, but it could also be a kite if, I'd say this was longer. Like if these 2 sides were longer, then it would be a kite. But either way, the formula is going to be the same for us. And here are our dimensions, I guess, that we're going to use for our formulas. All right, let's look at the parallelogram first. The area of a parallelogram is simply the base times the height. The base is one of the parallel sides, and the height is the distance between them. So in this case, we've got a base, we've got a vertical height, simply multiply them together to get the area. For our trapezium, it's a little bit more, this one looks a bit complicated, half outside of a plus b times h. But really what we're doing is we're averaging the tops and the bottom. Okay, so the bottom is a, the top here is b. We're averaging them. So if I add them together and divide by 2, I get the average of the top and the bottom, and I multiply it by the distance between the 2 parallels, which in this case is our h. For a kite, we use the diagonals, or a rhombus as well. We use the diagonals, we call them x and y, and it's simply half times x times y. So let's put some numbers on these diagrams. and we'll do some calculations. Our parallelogram is simply the base times the height of the parallelogram. Well, that's easy. 5 times 8. The units here are centimeters, and it's an area, so it's squared. In a trapezium, we're averaging the two lengths of the parallel lines. So I'm going to add the 8 and the 4, halve them to get the average, and then multiply it by the distance between them. In this case, 3 millimeters. I get a value of 18 millimeters squared for the area inside that trapezium. And for a kite, we're multiplying half times x times the y, which are the lengths of the diagonals. I've got a length of 4 and a length of 8. Straightforward, pop it into the formula, and I get 16 meters squared. All right, we've covered parallelograms, trapeziums, and kites and rhombuses. Let's move on lastly to the last shape we're going to look at, in this case, circles. Once again, we're talking about the area. So the space inside the shape or inside the circumference of this circle is called the area. We have an area formula for a circle, which is pi r squared. Now, pi is just a special number. It's a button on your calculator. Make sure you know where it is, and you simply put it in, multiply it by the r squared. Now, what's the r? Well, the r is the radius. We've got the distance from the middle of the circle to the edge is the radius. Now, be careful. In some questions, you might be given the diameter, which is the length across the whole circle, in which case you'd have to halve it because we're working with the radius. In this case, it's got a radius of 4. So where I see the r, I simply substitute in a value of 4. I can literally put that into my calculator as I see it. I could go pi bracket 4 bracket squared, and I'd get a value of 50.3. Now, the units are meters, but because it's an area, it's meters squared. Pi r squared, but we can modify that a little bit if we only have parts of a circle. Okay, so in this case, what is the area of this blue color? Well, I'm given the diameter, so I'm going to have to halve that to get the radius. So it's 4.5, which is the distance from the middle to the outside edge. So now I can use the 4.5 in my formula, although instead of finding the area of the whole circle, I only want the area of half the circle. So I'm going to put a half in front of my formula. My r value is 4.5. Put that in my calculator exactly as I see it. Half pi bracket 4.5 bracket squared. I'll get a value of 31.8. Hopefully you can see what we might need to modify our formula with this time. We've got a radius, so I can use my formula, pi r squared, but I only want a quarter of the circle. So in front here, I'm going to put a quarter, replace the r with the radius value of 12, and I get that value in millimeters squared. Guys, that's it. That was our quickfire snapshot review of the formulas for area of, what have we done? Squares, rectangles, 3 different types of triangles, 3 different types of special quadrilaterals, and circles. Good job. Well done.